Welcome, chemistry folks, to either this day 1 DLD on Monday for the white days or day 2 DLD Tuesday for the green day folks. Today we're going to talk some about atoms. Now, we've done chemistry for almost a year, and we've talked a little bit about atoms. We saw that they're indivisible and unbreakable, but then we found out because of the sticky tape lab, the atoms are made of smaller things. Positive goo and negative things that can move called electrons. A couple of classes I saw last week, and I asked them to draw pictures of what they saw an atom looked like. I'm going to share some of those with you. If you've not thought through what an atom might look like, maybe you think this. Atom, small, indestructible, perfect. J.J. Thomson's model was atom, small, yet made of positive and negative things. Useful. We know that they can stick together because of positive and negative things. Atom, kind of like an apple pie with things cruising around the outside of it. Lots of good stuff there. Maddie, too soon, not an atom. This is why we're home. We call that the Jimmy Neutron. Lots of pop culture and cartoon relevance. This is the modified Jimmy Neutron. Jimmy Neutron with some pieces on the inside of it. And finally, the super modified Jimmy Neutron. Pieces around the outside. Turns out somewhere in life we realized that atoms were made out of pieces. For us, that was Ernst the Mustache Rutherford, who shot things at atoms and realized that some of them bounced back. We know that there's a nucleus in the middle of an atom. We know that nucleus is tiny, 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 tiny compared to tiny atoms. And we know that on the outside there's these things called electrons. So your job today is to be able to count how many protons in the nucleus in the middle, neutrons, nucleus in the middle, and these tiny little electrons are on the outside of an atom. It turns out those things affect what the atom does and how it acts. So you spend most of your time on a website today. You're going to see it, a link for it below here. In just a second, this video is going to go to that website and I'll explain it to you. And then you're going to mess with that. You're going to play the game on that website. You're going to figure out how that works. It's really crucial that you can figure out what makes an atom have a certain number of protons, neutrons, and electrons, and how you can look at an atom and figure out how much of each of those things that you'll need. You'll need a periodic table. Maybe you have your reference sheet. Maybe you have to get one online. Either way, totally fine, but you'll need a periodic table to be successful on this task. And I will see you when you see my screen here in just a second. Toodles. I'm back, but my face has been replaced with my computer screen. When you get to right below where you're looking right now, you'll see this screen. Click on that thing and it takes you to a simulation called a PHET, build an atom. You should do all three of these. The first two you just kind of look at and do some things. This is an empty atom. There's nothing going on here, but you have buckets full of protons, neutrons, and electrons. And what you'll notice is that you can drag these things in here. If you put them in the right place, they'll stay. The protons and the neutrons go in the middle, the electrons on the outside, and it tells you over here which atom you've built. Oh, look, it says its name right there as well. You can change all kinds of things about these atoms, and as you change it, everything else on the screen changes. So this is helpful right here. Things you could think to yourself would be like, self, I wonder how I can make beryllium element number 4. Self, I wonder how I can make boron element number 5. The other thing you can check is the net charge as you change the number of protons and neutrons and electrons. The net charge changes. And finally, the last thing you can see is the mass number. The mass number of this one right now is 6. You could think to yourself, self, I wonder how I could get a mass number of 5. Self, I wonder how I could change it from lithium to helium. You can do all of these things, and you should learn a lot about these symbols here. Once you're done and you think you figured all these things out, click down on symbol. And it does the same thing, but this time all of those things have been replaced by symbols. So notice how the mass number symbol is up here in the top left. The total charge symbol is over here in the top right. And as you change things, that symbol changes. There's a fancy name here called the isotope symbol. That's what this is. But I just want to make sure you know how to put numbers in each one of these corners. That's a thing that's going to be really crucial. So play with this for a couple more minutes. And finally, click the game. There's a couple flavors of this game. They do get a little bit harder as you go, but this game is going to help you decide whether you have it figured out or not. It gives you a nice little ding and a smiley face if you get it right. I'm not going to do that because I don't want to give you answer 1 out of 5. Oh, yes, I do. How can I stop? This thing has 6 protons, 6 neutrons, and 6 electrons. I believe it is element number 6 carbon. Wait for the ding. I'm going to turn it way up. Ooh, tricky follow-up. I believe this one is electrically neutral. Check it, check it, check it. Oh, that was really loud. It was in my headphones, so you probably didn't hear it. Trust me, it was great. Play this game. When you're done with this game, you'll go back to our site, and there's a Canvas quiz on the next page. If you've got a little extra time, watch this thing. It's really fantastic. But try this Canvas quiz. Try it lots of times if you need to. Please write me some questions if you have them. Trying to figure out how many protons, neutrons, and electrons are in different types of atoms is going to be crucial for what we do next. Good luck. Let me know what questions you have. I'll see you soon.